Please send me a message or a comment. Ethan's already done that. Haley's already done that. Send me a comment because my ownership of my classroom, so to speak, does not allow me to see who subscribes. I thought I could, but I can't. So if you're already on there, great. Just send me a link, send me a message, send me a comment, whatever it is, and it pops right up on my screen. So that's how I've seen a few of you. All right, turn your books to page 233. Page 233, the guided practice. In order to add and subtract fractions that have unlike denominators, you need to convert them, right? You need to convert them. And what you convert them to is the lowest common denominator of the two numbers. Make sense so far? Well, example 1 in the guided practice says, what is the lowest common denominator of 2/3 and 1/2? So the question they're asking is, if you were to add these two items, what would you change 3 and 2 to? What would you change them to? Haley? 6, she's right. So if I were to add them, I would change 2/3 to some kind of 6 and 1/2 to some kind of 6. The way you do that is you convert both numbers by multiplying them by a fraction equal to 1. 2/3, for example, would get multiplied by 2/2, resulting in 4/6, right? I know they don't ask you to do that, but I'm just basically walking you through the steps. And 1/2 would get multiplied by 3/3, resulting in 3/6, okay? Now, that being said, you would go through the 3 through 10 and add or subtract by converting to the same denominator, right? Let's do a couple of these just to make sure you're square on how to do them. Look at number 3 with me. This is number 3. Find the sum or difference. -1/4 added to 1/8. What are we going to switch these both to? 8ths, 16ths, any ideas? Haley says? 8. So the first one, or the second item doesn't change. But the top item has to get converted to 8ths. And by the way, it stays negative. Okay, it stays negative. We're not changing the sign. We're simply renaming the fraction. We will multiply that fraction by 2/2, resulting in a -2/8. A -2/8 combined with a positive 1/8 is a -1/8. Okay? Everybody remember that? When you're combining negatives and positives, you find the difference and keep the sign of the larger of the two. That's number 3. Let's do number 6. 6 says 2 7/12 minus 9 2/3. Depending upon how you like to do this, you can either add the opposite or you can think of it as subtraction. I like to add the opposite. Okay? Add the opposite. But before I do that, I got to figure out what to convert these to. Let's convert them to 12ths. 12ths. So this becomes, we're adding 9 and 8/12ths, right?
Yeah.
The top one is 2 7/12ths. So when you add the opposite, you're really finding the difference between the two and keeping the larger. So it becomes -7 1/12. If you like doing it the other way, converting them to improper fractions and then converting them back, that's fine too. Whatever way you like. Okay? Let's do 7. Won't be too much longer. I'm only going to do a couple more examples. 8/15 added to A over 6. What is the lowest common denominator of 15 and 6? Go ahead.
30.
He says it's 30. He's right. What fraction equal to 1 am I going to multiply the first fraction by? 2 over 2 is right. So if you multiply 15 by 2, you get 30. A by 2, you get 2A. The bottom one, would you say 5 over 5? Let's do it. 5 over 5. 6 times 5 indeed was 30. 5 times A is 5A. The combination is 7A over 30. If this were reducible, as in the 7 and the 30 shared a common factor, we would reduce it. But since the 7 and the 30 don't share anything, we have to leave it as it sits. That's number 7. Let's do number 9. This is a subtraction one. 5A over 3 minus A over 6. I like to add the opposite. What are we going to convert these to? 6. So the bottom one stays. Negative A over 6. The top one gets multiplied by 2 over 2, giving us 10A over 6, right? 10A over 6 and negative A over 6 gives me 9. 9A over 6. Can the 9 and the 6 be reduced?
Yes.
By a factor of 3, right? So that becomes 3A over 2 because I divided both of those pieces by 2. By 3, I mean. By 3. 9 by 3 is 3. 6 by 3 is 2. Okay? That's number 9. Had you not reduced it, had you left it this way, I would have had to mark it wrong because we know how to reduce these. Last one I want to review with you before I let you get started is our lumber problem at the bottom. Lumber contains a lot of moisture. Before it is actually cut and sold to Menards to build a home with, it's dried. Okay? Suppose a freshly cut board weighs 10.5 pounds, then later that same board weighs 4 2/3 pounds. What is the weight of the water? It's the difference, right? It's the difference. It's what disappeared from the board itself. So if we start with the 10 and 1/2 pound board, and we remove from it the 4 2/3 pound of board, we end up with the moisture that has disappeared. Now, in order to do that, we need to change these to sixths, right? So 2/3 becomes 4/6. 1/2 becomes 3/6. Now, instead of converting to mixed numbers, I am going to simply borrow. I'm going to keep it as a basic subtraction problem for those of you that like it that way. And I'm going to borrow. Borrow from the 10, it becomes a 9. The whole that I borrowed is 6/6. Add the 6/6 to the 3/6, and you now have 9/6. Subtract 9 minus 4, and you have 5/6. Subtract 9 minus 4, and you have 5. Therefore, your answer is 5 5/6 pounds of water evaporated out of that board. That board shrank by more than half because of the moisture in the wood. Okay?